So let's start, and then I will maybe comment on. I'll give you a little more information on the exhibit with Echo. So it's so the best joke is with Pompous art. Okay, l'art pompant instead of art pompier, and Pompous instead of Pompous. So it's just to see what we may maybe some connection between fluid mechanics and art, and you have seen this morning some of that with the talk of the team on waves. I forgot the name. And thank you. Yes. And the first thing I want to show you is a few science images. And just to stress that in science, what we want to do with an image is to make a proof with that image. So we will use something that is very aesthetic for two reasons. One reason is that we have isolated one mechanism. So we have this, cooking down of all this, we want a pure phenomena. So we want to isolate one phenomena. So this is an aesthetic gesture already, just to isolate one part and to make it as clear as possible. And then we want to make from the image will be the proof of what we claim. So the status of the image is to prove something. And this will make, for example, this type of movie. This is something that will explain the structure of the ocean. So this is a tank, as for the exhibit. And we have created two vortices that will turn around each other. And what we want to show is that will happen just after a few seconds, is that these vortices will start to bend with a short length scale like that, and this will disorganize the flow on the vertical. So right now, this flow is getting disorganized, and what is interesting in science is that first there is this mechanism that is disorganizing the flow on the vertical. So this is a model of the ocean. The fluid is stratified, so the water is denser with salt at the bottom, is lighter at the top. So this is like a small model of the ocean. And what this movie is demonstrating is that this ocean should be in layers. And what is very important is that those layers are much smaller than the size of the layers that people have put in the model before we did this demonstration. So the whole purpose of this movie is to demonstrate that there is layers, and they are thinner than what you thought and thinner than what you put in your model to compute, for example, climate change for that. And so this is one way of doing maybe pretty or aesthetic image to demonstrate something in science. I will just take another example, is that if you want to, for example, to study tornado will die because they will go through a vortex breakdown. And to reproduce that in the laboratory, what we did, again, we went into the water because then the viscous effects are much smaller compared to the inertia. Water has much more inertia than air, so it's better to go in water than to do an experiment in air. And what we do is that we have on the top, so everything is upside down. We'll have a rotating honeycomb. So this is a series of tubes that will put a momentum, angular momentum into the flow, and then we go into a contraction zone. So this will accelerate the momentum, and we let the flow enter a big tank, and we observe with the same technique with the fluorescent dye to see what will be the dynamics. And when we do that, so here is to know when the vortex breakdown will occur, what is the shape, what will happen, and we want to do like a cartography of all the possible phenomena, then to say if you have a vortex, a tornado on March, for example, this tornado is in this point, in this parameter space, so it will be stable or unstable, it will happen something, so do some prediction. And to do that, we have also to do some experiment. So here there is a laser cut, the vortex is on top, and now I've lit another laser cut. So there is two laser cuts at right angle between each other. This is because this flow is very complex, and if we want to, if we look just in the volume, you cannot understand what is the shape of the flow. So to just unfold the shape of the flow, we need also to use very unusual, very specific way, for example, to cut the flow in one plane. and cutting the flow with a laser. So usually you don't use it's not very practical to read, for example, to use just a light slit. So here it's a light slit, just one plane where there is the light and no light outside, and with that we cut the flow, and we may explore the flow. So you observe one laser cut horizontal, so we were observing a double spiral, like a yin and yang shape, and when we cut vertically, we observe that. And here, because also of the way we want to observe to just analyze the flow, this also produces very unusual and particular aesthetic pictures. And you may say, okay, this is another picture, the first one we produce. And to me, it's a little like let's be selfish, it's a little like a guitar. And okay, no. But it will produce very amazing things. So for the scientific part, this is a proof that this very funny object is a double spiral plus instability on top of that. Pulsation, in a way. But again, this is just a scientific proof. This is another regime where now this will be a big cone. So and there is another regime where the flow will break in a big cone like that with instability inside and outside. So this is the way to unfold these dynamics. So we are facing a very complex dynamic, so we have to be smart in the way of analyzing that. So there is different reason to have very, very specific images. We isolate a mechanism. We have a very specific way of looking at that because we want to dismount, to make a proof, and the whole goal of the aesthetic part is to make the proof. And this will be the way we will convince people in the scientific community by maybe nice images like that. That what we are proposing has some scientific value for that. So it's a way, it's the carrier wave that is the art part or the aesthetic part for that. Now you may do something else. That is a scientific mediation, so vulgarization if you want. So this is a small tornado with the artist on the side. And for that I did that after collaborating with artists, so it will be with the same team of artists that a few pictures I will show you later on. So we start collaborating on different projects I will talk about. And for the 205 years of physics, that was a big international event, we want to make some physics exhibit, but we want to make it in a way as fun, as percutant, what do you say, as strong as possible for that. And the idea, in fact, doing that, we start working on this idea of a tornado. So here it's a big, so it's in the air. There is no water, there is smoke, but we may put water. And there is a light system, and the whole vertical, so it's like a vertical tube, is 4 meter high. The tornado itself would be 1 meter high. The enclosure is 1 meter 20 centimeter, and it's open, so you may try to grab the tornado. And to make it very, to convey or to fascinate the public, we made a few decisions to make the things in a way the more aesthetic as possible, but also the more intriguing as possible. And in fact, we discovered that doing so, we were adding trap. So it's not at all what we do when we do vulgarization of science. Usually, and I hate vulgarization of science, usually you try to make things as simple as possible. And since when you are a watcher, you do not understand anything, then you feel very, very bad, or you feel very dumb. The idea here is to make things very complex. And in fact, making this, so we add the complexity to make it very scenic in a way, very maybe aesthetic or very funny. But doing so, we complexify the physics. So, for example, there is light, and the light are with hot colors. And people looking at the installation, they imagine that this is we eat the plate just because there is hot colors with the light. So this is one trap. The other trap is that to unfold the dynamics of the tornado, we do intermittent injection of light. I have no movie, in fact, but we do intermittent injection of smoke. But doing so, you will see different part of the flow. So you see first, so there is no smoke. When there is no smoke, you see nothing, but the tornado is there. You put the smoke, you start just observing the core of the tornado, because this is where the vertical velocity is the largest, and we inject the smoke at the bottom. So you have the impression that a flexible neon tube is lit on very suddenly. It takes half a second to go from bottom to top. And after that, the smoke will reach different region. And then you will observe instability, different part. So in fact, you observe in time what is the structure in space of the tornado. But this will add one complexity to the flow, because people will start imagining that the tornado is creating and then is unstable. So there is different trap like that, and we realize putting that on exhibit with many people. So maybe it has been, I don't know, 40 times at least in exhibit with I don't know, 40,000 people watching that. That people were spending lots of time in front of that, trying to understand themselves something, and it was a very efficient way to do scientific mediation, instead of making something so simple that you are so dumb because you do not understand one thing of this exhibit. So maybe it's another way of doing pedagogy with the public, is to make things, to believe the public will be intelligent, and to put trap to make the flow as complex, or the interpretation or the understanding as complex as possible. So pedagogy by the complexity. For that, now I started doing art with one artist in 90, so more than 20 years ago. And at the start, I was maybe like, so this is one protocol of interaction with artists. Even now, it's also a protocol of interaction I do follow, is to just expand the possibility. So the artist is coming, and for example, he say, so I will show you a few examples of that. Let's go to one example. So for that, this is a piece. So this is the first one we start in the 90s, and it took us a long time just to get it on display somewhere. But the artist came with, he was doing in his bathroom 2 jets impinging, so 1 millimeter jet. And this is a very classical experiment in science by G.I. Taylor and maybe Savard before, and many people, is that what you do that, you will create a disk of water. And he came to me saying, okay, could you do that at large scale? And when you go at large scale, it's very different, because at small scale, the surface of the water is very rigid. It's very rigid. This is the largest force. It's much larger than the inertia of the flow. And this will smooth, in a way, if I make things very simple, this will allow to smooth the disk. At that scale, then you have to kill the turbulence. The flow wants to disorganize, so everything is inertia in the flow. So the challenge for the science was to kill all the turbulence and to create a smooth disk of that size. So here I was just, so he came to me saying, do you think it's possible? And I say, yes, we should try. And then we have to do something. Another things we did together, so he's from Crete, he called me in the summer. So we didn't know each other for very long, for a few years on the interaction on the other things. And he called me saying, do you think we may fly half a sphere on the very small jet? Because he got an idea of some installation, and I say, oh yes, we will try. And then, at the same time, but he did not tell me that, he submit a proposal to Cité de l'Industrie, and he was accepted. So by the time he came back from Crete, he was accepted to fly off a sphere in a small disk, and we have to do that. So here I was like the plume in the Dumbo flying artist. And I got very bad jokes like that. You have to get used to that. So with the same artist, we did another thing on the. So for that one, he did the same thing. So the collaboration with this artist, I was giving him some science. I was explaining the physical effect. Each time we were discovering something, and he was more mastering the imagination. So for that, he did also a very in his bathroom with a small tube, a small ping pong ball. He flew a ping pong ball on the small tube. He came to me saying, could you do that at large scale? And I say, as usual, why not? We should try. And that, so this was on display for the Printemps des Champs-Élysées de la Sculpture in 2000. And it's on display at Vittel Water Institute for that. So here it's half a ball flying on the size of a jet. And if you if it falls down because there is wind or anything, the water will bring the ball close to the jet, the ball will touch the vertical jet, and then it will raise as if he was taking an elevator, and it will raise to a stable point and stay there with turbulence and then flow again and back. So that is one way of interacting with people. So I start to maybe attract more crazy people. So this is another, so this was before the tornado. So the tornado is the large scale, the same idea but at large scale. So in 2001, in March, one designer, Jérôme Olivier, came to us saying that he was creating furniture for the future space travel. So you have to stay very long in the chateau, maybe years. And he was asking for tactile TV. So he came to us saying what idea you may have for a tactile TV. And with brainstorming, we ended up to do this tornado demonstrator, saying that people they want to bring the tactile TV was to bring some physical phenomena that exist on Earth but that do not exist in the space shuttle. And the idea was to bring a tornado, a small tornado that you may touch, and the big one is the expanded compared to that. So that's the tornado TV, one single program, but changing all the time. A little later, so that's an amazing story, because a little later there is a circus, the Cirque ici. I think it's Guillaume, the head of the circus, and he's in the winter he's in a residence in Calais, and he's preparing the new show. And he was doing a tornado in the circus, so with no trouble, with ventilator blower at the bottom of the circus, and then a big exhauster at the top. And with no public, he was creating a very nice tornado. And in Calais, they have 400 people volunteer to test the show. And as soon as there were 400 people in the room, in the circus tent, they were not able to get a tornado. So they call us and say, okay, we cannot generate a tornado, what we should do. And then, so they came, and what I did, I explained that in the tent like that, you have bright people, like right now. So bright people, when they think, you use 100 watts per person, if you think. And please don't think it's very bad for the global warming. So 100 watts per person. So 400 people is 40,000 watts, and there is a 10-degree difference between the top of the tent and the bottom. So the flow is stratified exactly like the ocean, and the flow will be split in layers. So they were imposing rotation in the bottom layer, but there is no way this rotation may propagate to the top. So I told them, put off the blower at middle above the public, and the other half at the bottom. And then there should be a tornado. If there is no tornado, we will go in Calais and help you. And in fact, they succeed right away to do the tornado with that. So no need to go in Calais and use a red nose to help them to do art for that. Now, maybe I will come back to that. So this is philosophical thought, but maybe I will go to real thing. And I come back to the discussion on that. So now I come back to this of a team where so we now are in a group of artists and scientific called Labo Factory. So this is with François Champfraud, that is a musical composer, and Laurent Cars, that is a designer and a plastician. I don't know exactly the term. And we do different, we have been working on different things. So the first encounter was, he came to me saying, I want to sculpture vapor. What can you do? So my answer was very simple. I may just do rings or tubes, because I knew I was able to do a tornado. And rings, this is a very famous experiment by Kelvin and other people. So and this is really a shared universe. So this idea was really to produce some, to immerse the public into a new experiment, or a new life, not life, but a new perception. So this installation, and I have a movie for that. And there is the sound. So really, for that, from the beginning, the idea was to build an art piece. So the contract between each other was really to build an art piece, not to do research. We need to do an artistic project. So this is the installation. So this was at the Nuit Blanche in 2005, and then it has been on different festivals like the Art Rock Festival in 2006, and then Syracuse. And this is an installation with 12 automatic drums, and each percussion in the drum will produce a ring, and there is also a specialized sound to give a different personality and to enrich the universe in which you will be embedded. So it's really to immerse the public into a different universe. And so this will be the starting of the Nuit Blanche. So the Nuit Blanche is all night long with a line of people. You have all these 12 ring generator, and for example, for that we share everything. So the music, there is some composition that are mine in the rhythmic. And what was amazing, what struck me, for example, when we choose the gelatin, the light filter, without talking between each other, we were with the same idea to put blue, very, and the sound was the same, very pale light, very sound that are not colorful. And the imagination, for example, for me, my imagination is that we are in the abyss. We are in the depth of the water. For the composer, it's more a morbid idea, but it's maybe the same. The abyss or something more morbid is the same. So we really co-create. The next one I want to and this is just a rush. So the next, with the same team, and it's good that we have directly the music. We did for when we launched 2010 another installation with Wave, and here the idea, let me just speak and put the so it's also an installation you may play, and here it's just the automatic sound here, but it's much better when you play the installation. And the idea was, so I was the proposal I gave them is that we may write music with infrasound. So the infrasound, you cannot hear them, they are too low, below 1 Hertz or a bit below 10 Hertz. And the idea was to emit the ultrasound at the surface of the water in the shallow layer of water. And in that particular state, the wave are on top of the water, they are the exact equivalent of the sound wave. They have the same physics, so they propagate like sound wave and they will be reflected. So in that installation there is, so that was the proposal, and to write the music, directly the composition. So this is the music with sound at the surface, you may see at the surface of the water, and then we, with a usual projector, we project through the water to produce ambrooscopic images, so light and dark fringes due to the cusp in the light on the screen. So the visualization is directly using light through the water. And there is 3 gisants, we call them, because it's also a kind of a morbid idea. This was in the church in Paris. So there is 3 horizontal tanks. We may emit wave at one end or at the other end. And they are all music, so you compose the music with that. And then this will, it's also, we immerse the public in the whole set of wave with sound wave, wave at the surface of the water, wave with the light in the whole church, and the whole church is just lit by this wave that are propagating in the church. So that's the idea, and you may just have an idea of what is the... it's really immersive experiments. So if you have to be in the room, you need to be immersed into that type of music, and it's very fun just to also play. Not with automatic music like that, but to play with the done and tell stories. So I've been playing hours during that day to play different stories. The audience is circulating around the church. So that has been shoot at some time in the night, but the people are circulating. We're not there to let the public touch the water, play with the installation, so they were circulating around in the smokes. It depends. For the Nuit Blanche, it's very strict. For the security, it's very, very strict. So you cannot leave the people inside. For the Artwork Festival, the people were allowed to go around the installation. For that. Let me move to back to just that. So that's this idea of wave and the music that you may see. This is Flandelis with echo, and maybe you will ask question for that. This is with echo, and I want maybe to show you one final thing, is that for me all that is what we use as a sculpture or as a material is the dynamics, so the form and its evolution. This is a single material you use to produce something. So you don't just produce with a dynamical process an object or a form, but the form itself is also this evolution in time. So it's a 4-dimensional object that you are sculpturing when you do that. That is in space and time. And the idea here, so I got that idea, so I just give you some of the pictures, that you may use exactly the same technique we use in science to unfold the dynamics. So when you have a space and time dynamics, what is very useful is to take a pile of image. This is a movie usually, but you imagine a pile of image, this is a volume, and then so one direction is the time, and then you may cut in the direction of the time. So in that case you produce a space and time diagram, and this has been used a lot to look at chaotic dynamics, pattern formation, all that. When you want to analyze the dynamics, you need that. If not, for example, if you watch the surface of water, you see a wave that is moving. If you do a cut, you may see, if it's moving with the same speed, you see a line. If the speed is changing, you see a different line. If there is 2 waves propagating in opposite direction, you see a set of lines that are crossing, like that. And the idea was to use that to analyze movies. Not to analyze, to produce pictures with movies. So this is from Abu Souf, and this is one plan séquence shoot of this movie, and this will produce. So this is So this is linked to waves because this is the Nouvelle Vague. And Nouvelle Vague, they were carrying the, but it's important because they were carrying the camera on the shoulder. And when you do a space-time movie, you have all this vibration that is due to the technique of shooting. If not, you see very uniform things. So we produce this type of texture with a motion that is given by the people who are shooting. This is smaller, but this is from Le Mépris, the final and the initial and the final stage. So the real image is, for example, if it were a print 40 centimeter high, this would be 40 meter long. So it's very unusual image just to print. I have some print of 15 meter long of that. So this is from the Mépris, and this is the red scene, or the reddish part, is the scene with Bébé naked, but Brigitte Bardot naked. But you may, and here it's this one, it's just to make connection with water. Here there is the water in the back, so you see the different waves propagating in the water. So there is the shooting, that I think the shooting, they were using a way to move the camera, so it was not with the shoulder, because it's very regular in the motion, so it should have been on wheel or something. But you have the motion of the camera plus the crossing of all different waves. So maybe I will end on that, and thank you for your attention. La philosophie. And I maybe put that just to read, but for the question. And now maybe we do.
One question about this talk.
Just add something, because I think I was leaving that for the question time, but I do not speak much on the collaboration between each other. But if I want to draw the collaboration, and maybe you may say no, yes, maybe Fleur de Lys, I explained a little the possibilities of what they were doing, proposing to put in the water, to use this the dye and things like that. So intruding a little in the universe. And the second one, it's more a fuse or a joint project where they want to, they were, as Echo explained, on this stream where they have this ambivalent use of the man-made clouds with this transposition and this idea. And the thing I want to show in that idea of climate change is that we are living in a very thin atmosphere. So we are in a space shuttle with no windshield. And the atmosphere is only 10 kilometers, but this is a gaze. And if we were putting liquid, if it were liquid, it would be just 10 meters. We know that because when we die, we have 1 atmosphere every 10 meters. And the oxygen part is only 1 meter 83 centimeters. So it's a little taller than me, but not much. So the atmosphere we are in is very, very small, very fragile. And the idea was to do a piece of art with these two ideas. The idea of a very thin layer, that is the atmosphere, and this atmosphere is itself the cloud, and it's thin, and it's already the pollution itself, or visualized by the pollution.
Okay.